I'm Mark Muszynski. I'm a civil engineer and I specialize in geotechnical engineering. When we think of what geotechnical engineering is, we have to think about what is attached to the ground. So everything that you can think of, every structure, every facility is somehow attached to the ground. And that's where geotechnical engineering comes into play. So we're talking about bridges, any types of buildings, towers, tunnels, roads, retaining walls. When we think about what's included with geotechnical engineering, sometimes I use as a synonym soils engineering or foundation engineering, but it includes a lot of geology, rock mechanics, and soil mechanics. The word mechanics in this context refers to how these materials, rock and soil, behave when we put a load on them. So that could be footing from your house. It could be if you drive your car on the ground, what happens to the ground? Or when you're walking on the beach, do you leave a trail or does the ground support you? Now, also in geotechnical engineering, we have to think about all of the other subsets of civil engineering. So that would include environmental, structural, water, transportation. And another one that we sometimes forget about, but it's still there, is the construction considerations. And that's what my talk has to do with a little bit, geotech and the construction. And so when we think about the trajectory of a civil engineering project, we plan, we design, and we construct the project. We have to think about what happens in the middle, though. A lot happens right here. And what's happening is making it all come together. And so in addition to all the subdisciplines, there's a lot of project management too, and that's related to the construction end of it. Some of the skills that I'm talking about to make it all come together, in a nutshell, it's communication, but we're also talking about site safety, cost tracking, resource management, all the things a project manager would do when they're constructing a project. A lot of the time, a construction manager is also a civil engineer, or they can be a civil engineer as well. This is just a little excerpt of a construction schedule called the Gantt chart, just showing various activities right here, and then in bar chart form, showing where those activities take place with respect to the other activities and the durations of those various tasks. Now, this is an example of a consulting project I worked on. And in this case, the construction manager hired our firm. I do consulting, as Dr. Shimabuku mentioned. Some of us do consulting. Some of us do research. Many of us do both. This was a project that a construction manager wanted us to look at a couple of things. And that is for a new hospital, which is right in this area here. Wish my cursor was just a little bit bigger. But this is the new hospital, and it comes around here. They were wondering about how to position these cranes so that this hospital could be constructed. So that involved looking at the zone of crane reach to see where these cranes can swing. And also we had to think about the crane pads themselves. So it's something that we don't normally think of, but the crane pads have to be strong enough to support the cranes so that we can maintain site safety and build the facility. And so cranes usually have outriggers of some type to help support it. You can imagine if a crane is holding a load positioned like this, these outriggers here shown in red would have the most pressure on the ground, pressure being a force divided by an area. So there's a force coming down divided by this area over that pad. And so we don't want to overstress the soil in those areas. Now, different types of soil have different amounts of pressure that you can put on the soil, ranging from hard rock to wet clay. And again, we need to keep these pressures below a certain allowable pressure, which is again a force divided by an area. We even have to think about the geometry of the site. So here's a side view or a profile view. If we put a load here on this outrigger, because we have this little embankment here, we can push the sand out or the soil out more easily in that case, and that needs to be taken into account. And things like this can happen. These were bearing capacity failures on these cranes. This one has outriggers. This was just one on tracks, but it had a bearing capacity failure at the front end. And usually when a crane starts to sink into the ground, it's usually not a good thing. It usually goes over very quickly. It's very dangerous. And so this is an excerpt of the actual notes that I gave to my design team in my consulting firm. And later we converted these to a CAD file for our client, showing the design of the crane pad. And so some of those things were taken into account concerning bearing capacity. And so again, these are the various things that come to mind for me when it comes to making it all come together from a construction or a project management standpoint. And I like to refer to these things as people-person skills. And to me, that's what makes civil engineering so exciting. It's not just drawing up plans, it's actually drawing up plans for the public, for your client. You're working with people. And that's what adds a lot of richness to the profession for me. And I think that's why you've made a good choice with civil engineering.